Hello everybody, thank you so much for coming to the Jordan Duclos Guild fundraising auction. I really appreciate that you're here tonight. I'm not able to be with you tonight because I'm in Brisbane, Australia, working on my sabbatical. I'll tell you more about that in a few minutes. But I really want to take this back to why we're all here. I was one of Jordan's doctors a number of years ago when she was a little child with a brain tumor. I took care of her and her family, and we became very close in the process of doing that. This is a guild that commemorates Jordan. This is a guild that supports research on pediatric brain tumors so other children don't have to experience the same things that the Duclos family experienced. And most importantly, this is a guild that changes the way we're going to practice cancer care for all cancer patients, whether they're little children like Jordan or whether they're adults like Kristen, who you've heard about more tonight. In the past number of years, the Jordan Duclos Guild has funded the absolutely most outstanding, most innovative work that our laboratory has done. As I've mentioned in the past, the work that we do that's funded by NIH tends to be iterative work. It's things that they fund because they know we're going to be able to pull it off. But that doesn't get you very far when cancer is your enemy. Really what we need to do instead is to make big, bold moves. We need to be able to see things that we might be doing 20 years from now and take the first steps towards that. These projects are likely to fail in many cases, and a lot of the work that we do does fail. But in fact, if we don't take those bold steps, we can't ever make the successes. Tonight I'm going to bring you up to date on where we are with two of our main projects that this guild has funded in the past. The first of those projects is the drug array device that I first told you about last year. You remember that I talked about my frustration as an oncologist, that when I prescribe a drug to a child who has cancer, and I have no way of knowing whether or not their cancer is already resistant to that, to me that feels like a black box that's absolutely unacceptable. So many of those kids, in fact 90% of them that have recurrent disease, are prescribed that medicine, they take that medicine, they have the toxicities from the medicine, but they don't get any benefit from it, and that's just absolutely not acceptable. So I charged my team to develop a way that we could introduce multiple different chemotherapy drugs right into the patient's cancer, and that by introducing those drugs we could see which ones worked and which ones didn't work before we ever prescribed it to the patient. And we've made huge progress on that. As you know, for some of these things that we want to bring into patients, there has to be a company behind it. And we formed a company last November that will commercialize this technology for human patients. We found investors just this week. As I'm preparing this video, we've met and exceeded our first investment goals. We've hired one of the most talented CEOs from San Francisco that I could possibly ever imagine having, and we've built this incredible team that includes some of the people that you've funded in the past that used to work in my lab, who will now be taking the engineering lead on this. More importantly, as we were developing this work and trying to think about how to bring it into patients, we also realized that there was a place for this in the development of new drugs for cancer patients. As it turns out today, and I believe this will come as a surprise to you, it certainly was a surprise to me, the way that drug companies go about discovering and developing chemotherapy drugs for patients is backwards. It's something that I just can't explain how frustrated I was to learn exactly how it happens. Right now, drug companies find their targets that they want to go after on cancer cells that are grown in plastic dishes. They then take these cells that are grown on plastic dishes and find out what it takes to kill those cells. But the problem is the same thing that kills a cancer cell that's grown on a plastic dish and fed with calf serum and incubated in all these artificial conditions often has very little relevance for cancer cells that are growing in a patient, that are talking to each other, that are in clusters, that have an immune system and red blood cells and nutrients coming from the patient's own body. This is the reason that drug companies experience a 90% failure rate in the drugs that they develop. Not only do they identify their targets on those cancer cells that are grown under artificial conditions, but they then do all their screening, their validation, their prioritization, and before it can ever go into the first mouse to see if it has any efficacy, they have to make it look like a drug with medicinal chemistry, and they have to do all the pharmacokinetic studies that help determine whether or not that drug can get to the cancer or not. So the first time that a cancer drug ever sees a mouse with cancer to see if there's any efficacy is about 2 to 2.5 years into the process, and by that time there's tens of millions of dollars behind it. People are attached to it and it's hard to let it go. They can then optimize it, they can put in hundreds of millions of more dollars behind it, but if it starts with a false premise, you really are not going to get very far. So what this company that we've started, and with the technology that you've helped support, is going to be able to do is to take human cancers that are growing in mice and to inject 10 different ways of knocking down individual genes to see which ones actually kill cancer cells when they're growing inside of a living being as real cancers. This isn't as fast as what the drug companies can do right now. They can do 10,000 molecules a night, but we can do 100 in a month, and we can expand that over time so that we can do thousands, and pretty soon we'll be up to the point where we can really go through the most critical drug targets in a relatively short period of time. We've already had very favorable discussions with Merck and Pfizer about bringing this in, and they've told us it's the perfect time. They're really looking for new targets. They recognize that the way they're doing things right now is not the best way to do it, and they're looking for help, and we're hoping that we'll be right there to help develop new drugs that work better for future cancer patients. Moreover, we can even prioritize the drugs that they've already identified and help them identify combinations of drugs that ordinarily wouldn't be used together, but by introducing the combinations and comparing those, we can identify ways that they can effectively shut down the communication patterns in cancer cells that are needed for the cells to grow.